Okay, so we should be recording. My name is Brittany, and this is my Module 3 on missing data and exploratory data analysis. I do want to say that I have two separate videos. This one is going to go over missing data. The other one, part 2, will go over EDA. It's just the way that I've found that it uploads the best. I've tried this 200 times. So anyways, let's jump into it. What is missing data? It's something that every researcher deals with. It's frustrating, but it happens. So it's more specifically, it's something that the researcher has intended to measure a value or the variable, and it isn't collected or it isn't stored. And whether that's an RA's fault, whether that's a problem with the design, whether it's with the participant, it happens. Missing data happens. And there's 3 different types. There's missing completely at random, which is acts of God or nature. The equipment malfunctioned, the participant had car troubles and missed the appointment, so the data wasn't collected. But the important thing to note is that the probability of that missed observation is absolutely unrelated to the value of interest of that particular variable. So there's no correlation between missing this and whatever you're measuring. So with MCAR missing data, it's still going to remain unbiased. Then there's missing at random data, and the major difference from that and MCAR, or between that and MCAR, is that the missingness does not depend on the value. Although it may look like it, after controlling for another variable, you discover that that's not the case. So I conceptualize this by just thinking of random examples in my head, and I thought of obese people may not report their income. They may also not make a lot of money, or some of them. So one would think that the reason they're not making a lot of money might be why you're missing data on the actual income. However, if you dig further within the sample, the probability of reporting income was actually unrelated to what they make. And that's what classifies it as missing at random. There's no correlation. We can still produce unbiased parameter estimates. So then the last one is missing not at random. And you can always tell the people who aren't going to come back for their second trial, or the people that they're like, oh, let's do the survey over the phone, and then they never answer your phone call. So going back to my other example, maybe obese people are less likely to report how many high-fat foods they eat, or maybe depressed people are less likely to report their mental status. So all of these types of missing data will lead to biased parameter estimates, and then we sit here as researchers and have to figure out how we actually account for all of this. But before you ever run a study, you always want to think about how to prevent missing data from happening. It happens at the participant level, so how you recruit for participants, who you recruit. Do you have incentives? What about your measures? Are they too hard? Are they too long? You want to make your project worthwhile for your participants. So again, it also could be who's on your research team. Are they going to call out when it's their turn to interview a participant? It goes all over the place. So you always want to think of ways before data collection to prevent this stuff. You can always do a pilot study to see what happens. And then if it does happen, there's so many ways to deal with it. There's deletion, and you could do that list-wise, which is traditional and easy. Overall, you just omit those cases completely. You don't even run the analysis on whatever remains. So, unfortunately, the disadvantage to list-wise deletion is that when you delete your sample size, you delete a participant, you decrease your sample size, which definitely affects the power. So you're going to experience loss of power, and whether you have a small sample size or a big sample size, that'll happen on different levels, but it does happen. Validity can also decrease depending on what type of missing data it is. There's also pairwise deletion, and you only delete what's missing, and then you use the existing data from that participant for other analyses. And that disadvantage is that your parameters of the model become really wacky, or can become, depending on how often you have to do pairwise deletion, because then we have different sets of data with different sample sizes and different standard errors and just differences. So you got to become really vigilant when you run further analyses on that. Then there's imputation. And what I found out is it started back with the Census Bureau in the 1940s when they would send out the survey. And what was going on is that they weren't getting back a lot of the surveys from the African American participants because, well, who knows. So what they did was they had just a database, and they would pick at random a person and substitute that person in for whoever was missing. Today we do similar things. There's mean substitution, which is if you have a missing value, you just substitute the mean for that variable. There's no new information that's added. It underestimates the error. There's small changes in the correlation coefficient and almost no change in regression coefficient. So it's like, what are you actually taking care of? Because you're increasing the sample size, but you're not adding any new information to the set. So there's mixed feelings on mean substitution. There's regression imputation, which is just linear regression to help predict what the missing score should be based on variables or values that you already have. Going back to my obesity example, I would rather do regression imputation because it's going to be a more realistic number if I'm missing somebody, a male, 300 pounds, versus if I do mean substitution and I take the weight mean for all of my sample, which includes children, women, whatever. The disadvantage is you're still not adding anything new, but you did increase your sample size. However, you reduce the error, but that does reduce the error. However, you could experience some biases because that number, that value you just entered as for the missing person was created from your own data. So it's kind of like already in favor of whatever you have going on. And then there's multiple imputation. And that's when you randomly just fill in missing values from other subjects over and over again. You do this by generating multiple data sets, comparing them. And although we don't want drastic changes, we do want some variability. And that allows us to obtain that. So I think multiple imputation is something that's more common dealing with missing data. With reporting data, missing data, you always want to talk about what you did to help prevent it. You want to go into your diagnostics about how you identified it, how you treated it, different sensitivity results, and so on. You always want to make sure that you cover all the angles. So that is my portion on missing data. Stay tuned for the second part 2 that goes over EDA. Thank you.